Hello all, in this video we will see the conversion of regular expression to NFA. In the previous couple of videos we have seen that a token will be specified using regular expression and will be recognized using an automata. So this is very essential to convert a regular expression to automata. So we will see an algorithm known as Thompson's construction. Thompson's construction to convert regular expressions to NFA. So before that, we will see how we will convert smaller parts of regular expressions to NFA. For example, if you have the regular expression A that can be converted to the NFA like this, that is, there will be a start state, some I, and on A it can reach the final state, some F. Okay. Now if you have epsilon is a null string, you know that. And if you have epsilon, NFA for epsilon can be drawn as there is some start state I, and on epsilon you can reach some final state F. Now if you have something like, you have NFA for S, some regular expression S, and you have NFA for some regular expression T, and if you want to draw the NFA for S union T, that will be like this. That is, you have NFA for S, you have NFA for T, and now the NFA for N of S union T or S or T can be drawn as: introduce a new start state I, connect to these NFAs using epsilons, and connect these automaton and these two individual automatons to a final state F using epsilons again. So that is, you can connect the automaton for S and automaton for T using epsilons to the start state and final state. Now if you have automaton for S and automaton for T, and if you want to draw the automaton for S concatenated with T, you can draw it as: add a start state I, new start state, then draw the NFA for S, include the NFA for S, then connect this NFA by epsilon to the automaton for T, and connect this automaton with the help of epsilon to the final state F. Now, if you want to draw the NFA for, if you have the NFA for S, and if you want to draw the NFA for S star, star means 0 or more occurrence of S, it can be drawn as, which is include a start state I. Now, draw the NFA for S, that is, include the NFA for S. Now you know that S star means it can be repeated any number of times. So you include a loop on epsilon. Without any input, you can repeat this any number of times. Connect this to a final state using epsilons. Here also epsilon. Now star means 0 or more occurrence. That is, even if this S doesn't appear, this is pretty fine. So that you can bypass this NFA for S using an epsilon. So this is how we design NFA for the simplest units. That is, for NFA for A, simply reach the final state from the start state using A. For epsilon, reach the final state from the start state using epsilon. For S union T, draw the NFA for S, draw the NFA for T, and connect them to a start state and final state using epsilons. And if you want to draw the NFA for S concatenated with T, provided you have the NFA for S and T, you can simply concatenate the NFAs using epsilons. Now if you want to draw the NFA for N of S star, you can draw it by drawing the NFA for S and connecting it to a start state and final state by epsilons. Now S star means that S can be repeated any number of times. So just give a loop on epsilon. That is, even if you don't have any input, you can repeat n of s any number of times. And star indicates 0 or more occurrence. So even if it is having 0 occurrence, it should be fine. So you can bypass this S using an epsilon directly from this start state to the final state. So if you are wondering how to draw the NFA for n of s plus, where plus indicate one or more occurrence, n of s plus is nothing but s dot s star. See, s dot is s plus is s dot s star, that is s plus means one or more occurrence. So for one occurrence, this more occurrence s star. So you can simply concatenate the NFA for s and s star to get s plus. Okay. Now we will see an example, a couple of examples. So we have the regular expression for the sake of an example. Take the regular expression A over B the whole star ABB. See, here the individual units are A is there, B is there. These are the two individual independent or smallest building units. So you have to again A, B is repeating here also. So you have to draw NFA for A and NFA for B definitely. So we will draw NFA for A first. So R1, we will give it the name R1, NFA for A. That is, NFA for A can be drawn as some start state 0. Now upon A, you can go to some final state 1. Okay. Now the other building block is B. We will draw the NFA for B. So some start state 2, you should be giving the next number. Then on B, you can reach the final state 3. Okay. Now it is A or B, isn't it? So see whenever you are evaluating, the concatenation part should be evaluated first, then only OR part. So if you want to evaluate the concatenation part, this part should be ready and this part should be ready. So we will see NFA for A or B. So R3 is A or B. See, NFA for A or B can be drawn as I have told you earlier, NFA for A is 0, A, 1. This is the NFC. We won't draw any final states because we are including new final state. This is NFA for A. Now NFA for B is 2, B, 3. This is again we won't be drawing any final states because we are including new final states. So NFA for A, NFA for B. Now what we have to do is connect these two NFAs to a final state, new start state and to a final state using epsilons. Alright. Now A or B is ready. Next thing that we want to draw is A or B the whole star. So as I have told you earlier, A or B, so we will give it the name R4. R4 is equal to A or B the whole star. So we have NFA for A or B already, which is R3. Now we have to draw for A or B the whole star. So we can simply copy this first and we'll add the new start state and end state. So 4, I'm simply copying it, 4 epsilon 0 A 1 epsilon. Again we won't be drawing the double circles around the final state as we will be including a new final state. Epsilon 2 B 3 epsilon to 5. So this is the NFA for A or B. Now to include star, you know that you should be adding a new start state, say 6, and new final state, say 7. Now as it is A or B the whole star, this NFA should be able to be repeated any number of times, isn't it? So an epsilon, a loop, so that any number of times it can be repeated. From 4 to 5, any number of times it can be repeated. And as it is A or B the whole star, even if the A or B is completely absent, this should be working fine. So you can completely skip this and go from the start state 6 to the final state 7. So that is the NFA for A or B the whole star. Now R5 is A or B the whole star dot A, the first state here. So for that you have to simply append the name. So we are simply copying the whole thing. Keep in mind, I repeat, the double circles around the final state won't be put, as we will be including a new final state. Whenever we are adding something, we will always be including a new final state. So the double circles around the final state will not be put. We'll be simply copying the state but not the double circles. So I'm not copying the double circles around 7. Now to concatenate A, simply add epsilon, then add A and make this the final state. Okay. So in the next iteration you have to add this B and one more B, isn't it? I'm not drawing the new diagrams, I'm simply making the changes here. So this is 9. So to add B, add an epsilon, go to the new state, add B, add another B, add an epsilon, go to the new state and add the new B. So the D. So this will be the final state. So see, this is A or B because two separate parts for A and B, A or B, the whole star, then A, B, B. So this is how we will draw NFA. We will convert regular expression to NFA. We will see one more example. We will draw the NFA for the regular expression AB over CD the whole star. See, so the first thing is you have to draw NFA for A, B, C and D. So for R1 I am taking as A, NFA is and new start state 0, then upon A it goes to the final state 1. Then for B, R2 is equal to B. The NFA is from the start state 2. On B, it goes to the final state 3. Now for 3, drawing it for C, R3 is equal to C. On start state 4, on C, it goes to the final state 5. Now for D, R4 is equal to D. On start state 6, on D it goes to the final state 7. So these are the NFAs for A, B, C and D. Now we have to draw for AB, and you know for AB you just have to concatenate the NFA for A with the NFA for B with an epsilon in between. So NFA R5 is AB. So NFA for A is 0, A, 1. I repeat, the circles, double circles around the final state will not be drawn as we are including a new final state. Yep. Then A. Now the NFA for B is 2, epsilon 2 on B we are going to 3. Now the final state for second NFA can be made as the final state, or even you can add a new final state, whatever you prefer. If you want, you can, to make things simple, you can make the final state of the second NFA as the final state of the NFA when you are concatenating NFAs. So A concatenate with B. Now R6 is, see, this is concatenation should always be done first, as I have told you earlier. So A dot B first be done, then A C dot B should be done, then only you can do this OR, because concatenation is preferred over OR. So you have to draw for CD. So again, for C it is 4 C 5. Now we will concatenate the NFA for D, just using epsilon 6 D 7. And as I have told you earlier, if you want, you can draw, you can retain the final state of second NFA as the final state when you are concatenating NFAs. Otherwise, you can add epsilon and include a new state, that is completely up to you. Now R5 and R6 are obtained. Now you have to have to take OR on them. So for taking OR, you know that is NFA for, that is R7 is equal to R5 or R6. So NFA for R5 should be drawn first. 0 A 1 epsilon 2 B 3. Now NFA for B, NFA for CD, that is R6, R5 or R6. So R6 4 C 5 epsilon 6 D 7. Oh sorry, you can't draw double circles around the final state, because we are going to include a new final state. See, now NFA for R5 is ready, NFA for R6 is ready. For drawing R5 or R6, you just have to draw both the NFAs and simply connect both to a new final state and new initial state and a new final state using epsilons. This is as simple as that. Now NFA for A, that is R5 or R6, then R8 is R7 the whole star, isn't it? R5 or R6 the whole star. R5 is this, R6 is this, the whole star. So for drawing NFA for the whole star, I'll be making corrections to this NFA. Hope that you have this with you. So I'm just making the correction here. See, for drawing, this is R7. To draw R7 star, what you have to do is include a new start state. So say 10, include a new final state. So 11. Now loop this so that this can be repeated any number of times. Now R7 the whole star means even if R7 is absent, this is pretty fine. So you can directly go from the start state to the final state upon epsilon. So this is the final NFA for AB or CD the whole star. See, AB is on one line, CD is parallel to that. It can be repeated any number of times even if that whole thing is absent. That is, even if this whole term is absent, the NFA will take you to the final state, and the reason is this is AB or CD the whole star. Star means 0 or more occurrence. So even if the whole term is absent, you can go from the start state to the final state on epsilon. So this is how we convert regular expression to NFA. This is really important in the sense that tokens are specified using regular expressions and recognized using automata. So we should be knowing how to convert regular expression to automata. And this is how we do this. So while doing this, please keep in mind that concatenation is always preferred. Concatenation is the highest priority operation and OR comes only after that. So everything else is easy. And one more thing is S plus is equal to S dot S star. That is, if you know how to draw S star, you can draw S plus by simply concatenating it with an S. So that's all in this video. Thank you.